Okay, here we are, chapter 6.2, perimeters of composite figures. We just got done with circles and we talked about the circumference of a circle. That's the distance around a circle. And perimeter is a more general term that you should already know, that is the distance around things, but it's usually around rectangles, triangles, and figures that have straight edges. But we're going to talk about composite figures today, and composite figures are figures that are composed of more than one thing. It's a composite means that it's a combination. That might be the best way to talk about composite. So perimeter of composite figures means the distance around figures that are made of a combination of shapes. So we have a combination of figures, combination of shapes that make a figure, and we're looking for the distance around. The book says a composite figure is made up of triangles, squares, rectangles, semicircles, and other two-dimensional figures. So they give examples. They have a rectangle that has a triangle on it. Okay, this would be a composite figure. They also have a rectangle with a half circle on it, and I can't do a half circle with a tool, so I have to just draw a freehand half circle, and so you're going to have to forgive me because they're not going to be very good. Okay, so you also could think of something like like an ice cream cone with a little half circle on the top of it. See, it's sort of like an ice cream cone is kind of a composite figure too. Now this doesn't have the line. The line here would mark partly the end of the triangle, but also the diameter of the circle. And we will need the diameter of the circle if we want to get the distance around half of a circle. See, so we got to find the distance around a whole circle, and we cut it in half. Now, the first thing that we start off with, is this is a picture of an arrow. And I'm just going to draw one and hope it turns out all right. Go to there. And it won't be perfect, but it'll be close. The book does a better job. Okay. This is an arrow, and we need to find the distance around the perimeter. Perimeter equals the distance around. Oops, got to have the P equals the distance around. So we just go start counting. Let's pick a decent color. Count the edges. 1, 2, 3, 4, 5, 6, 7, 8. So this side is 8. That means this side is 8. This is 1, 2, 3, 4. And then this is 2. And this is 2. So that's 2 and 2. Now, we have this diagonal edge, and they want us to recognize the fact that this is called the hypotenuse of a triangle, the long edge of a triangle, if it's a right triangle. I guess this might not be a right triangle. Anyway, oh, it is. When you take a square, if it's an actual square and you cut it in half, let's draw that. This is almost a square. If you take an actual square and you cut it in half, this is a 90-degree angle, and this is a short leg, and the long leg is called the hypotenuse. They're wanting us with a square to estimate this one is about 1.5. I didn't draw that very well. 1.5 as long as this one. So about 1.5 times as long as the short side. So we're just going to count these, and then we're going to have to multiply them by 1.5. So 1, 2, 3, 4, and then there should be 1, 2, 3, 4 over here. So that's 8 long ones. And that's kind of just an estimate. It's not going to be exactly 1.5, but that's what they want us to use. And we're going to multiply it by 1.5. So 1 times 1.5. This is a place where I like to use a fraction. I just think 8 times 1.5 and a half. 8 times 1 is 8, and 8 times half is 4. So that would be 12. If I did it another way, I could change this to 3 halves. And then I would just simplify 8 halves down to 4 ones, and then 4 times 3 is 12. I still get 12. If you use a calculator and you go 1.5 times 8, that's 8 times 5 is 40. 8 times 1 plus 4 is 12. And then remember to put your decimal back in. There's a decimal right here. It gets 12.0. Either way, we have 12. So this total distance is 12. So we'd have, I guess, 6 here and 6 here. And then we just add it all up. 6 plus 2 is 8. 6 plus 2 is 8, which gives us 4 8s, which is 32, plus 4 is 36. So this is about, we have to say approximately, because we're kind of estimating our distance here, about 36. And we don't know if it's inches. I guess we'll call it inches. About 36 inches around this figure. That's how that works. That's how you do it with grid paper. A lot of times it's just going to give you the shape. For instance, they might give you this shape. It's like a triangle. And then this one, they do dotted. They do a dotted line here, but I'm just going to draw the line. And then they draw the the rest of the, you have to draw a half circle on this. So it's a half circle. And you're finding the perimeter around the whole thing. They give you that this is 8 feet. This is 6 feet. This is example number 2. And the diameter is 10 feet. Okay, so basically we have 2 areas. We've got to figure out our circumference and then divide it by 2, because a whole circle has a circumference of 2 pi r. That's the formula I remember, and then I can come up with d times pi, because 2 times r, the radius, is halfway across the circle, and 2 times the radius is the diameter, so it's just diameter times pi. And so circumference equals diameter times pi, and since we're doing a half circle, we're going to divide it by 2. Alright, so it's 10 times 3.14. 10 times 3.14 is 31.4 over 2, and I'm going to have to use a calculator for that. 31.2 divided by 2 equals, oop, I did it twice. That means I have to clear it. Or I could just times 2. 15.6. Somehow I did it twice. Hopefully you guys saw. I guess I'll just clear it and do it again. 31.2 divided by 2 equals 15.6. Right here. Oh, 31.4 divided by 2. Well, we know what that's going to be. .4 divided by 2 equals 15.7. Really? Close enough, I guess. Equals 15.7, which is 15.7 feet. That's for the half circle. So that makes sense, because it's about 3 times as far around the circle, which 10 times 3 about 30. And this is a little more than half of 30. And we have to add it to the 6 and the 8, plus 6 plus 8. And if we add the point zeros, then we have 7, 14, and 1 is 19. So 29.7, if I did all of my math right. So the perimeter equals 29.7. Now P, capital P, make it a large P, stands for perimeter. That's just how that works. Okay, so you have to find two of the pieces and find the way to do it. That's basically how you do everything in this lesson. You've got to figure out how to find the perimeter, and sometimes it's easier than others. That you might have to find some hidden sides, some edges, but you'll be able to do that. For instance, if it gives you, I guess we'll just use this one, and I'll draw it real quick just to see if I can. You have to imagine that these are all straight sides. Okay, now if it gives me this and it says this side is 10 and this side is 5, can I figure out what this edge is? If it doesn't tell me and it just leaves that blank, can I figure it out? I can. If it tells me that this is 18 and that this edge is 9, can I figure out what this edge is? Because it has to be 9 also, because 9 plus 9 is 18, and these two add up to the same length. And this length is 10, so this one has to be 5, because 5 and 5 have to add up to this length here, as long as these are all square edges, and we're assuming that they are. So that's the only other thing that might cause you some trouble, is the hidden distances. Other than that, just have fun with the lesson.